Amol Sawant, Department of Civil Engineering, KIT College of Engineering, Kolhapur. Today we are here to discuss on the course Advanced Design of Concrete Structure. First of all, we see the broader objectives of the course. First is identify the provisions made in IS 456-2000, IS 3370-1984 and IS 1346. Second, develop the concept of yield line theory. And third, analysis and design of different RCC structural elements, water tanks and retaining walls. Now today we are discuss on the unit flat slab. In the last lesson we are discuss about the introduction of flat slab, advantages, disadvantages of flat slab and first design of first analysis method, that is direct design method. Now today in this lecture we are discuss the second method of analysis, that is equivalent frame method. The objective related to that lesson is analysis and design the RCC structural element, that is flat slab. Now see what is equivalent frame method. The equivalent frame method is more general and is based on elastic analysis. The structure is divided into frames in longitudinal and transverse direction. Thus, the actual three-dimensional structure is considered as a series of equivalent panel frames. Each consists of a row of columns and portion a systematic turbidity to it. In each direction, the equivalent frame consists of a row of columns or supports bounded laterally by the center line of panels on each side of the row of the column or supports. The frames adjacent and parallel to the edge are bounded laterally by the edge and the center line of the adjacent panel as per clause number 31.5 of IS 456-2000. Some more assumptions are made ready or regarding the stiffness of the frame members. Gross area are assumed and the stiffening effect of the fatted column is ignored. What is fatted column? The column head which is provided at the top, the stiffening effect of that column head is ignored in this method. The equivalent frame method can be analyzed under both gravity and lateral loads using any standard computerized software based on the finite element method. Means any software or standard software based on the finite element method, by using that software we can analyze the building or we can analyze the frame. The concept of substitute frame can be made using of instead of analyzing the frame slabs with width method. Means normally what we do the analysis by effective slab width method, but here substitute frame is used to, or concept of substitute frame is used to analyze the frame. Since the standard computer software is usually employed in this analysis, more details and examples using the FEM are not included in this lesson because the software is employed. So, in this lesson we are not going to discuss any example or more details. We are just discuss the theoretical part or theoretical portion of the equivalent frame method. Now, in this equivalent frame method, how to distribute the bending moment across the panels. After distributing the moment longitudinally as a positive moment in span and negative moment at the two ends, the next step is to apportion them transversely to the column strips and middle strips. Means first of all you calculate the longitudinal moments as a positive moments and transverse moments as a negative moments, and then proportionate that moments into transverse direction into column strips and middle strips. Means total moment, first of all you calculate the total moment on the slab and then distribute that into two parts, negative and positive. Again that moments are proportionate to the column strips and proportionately transfer to the column strips and middle strips as per clause number 31.5.4 of IS 456/2000. The transverse distribution of moment to column strips as per clause number 13.6.4 of ACI 318. For the slab with beam between supports, the slab portion of the column strip should be proportionate to the portion of column strip moment not resist by the beam. Means we are eliminate the structural element beam. So whatever support or whatever the moment carried by the beam, that moment is distributed in the column strips instead of distributing that moment in the beams. The torsional constant C for T or L beam is calculated by subdividing the cross section into separate rectangular parts and summing the value of C for each part. As per clause number 31.5.5.4 of IS 456/2000, the moments in the middle strips are assigned as follows. The portion of a negative and positive factored moment not resisted by the column strips in proportionally assigned to the corresponding half middle strip. Second, each middle strip is proportionate to resist the sum of moment assigned to its two half middle strip. A middle strip adjacent to a parallel with a wall support aged in a proportionate to resist twice the moment assigned to the half middle strip corresponding to the first row of interior support. Now see, if you refer that figure, whatever I discuss in a theoretical point, this is in the form of graphical representation. The total moment is calculated. 75% of that moment is act in the middle strip, whereas the remaining 25% is act on the column strips. See 0.125, 0.125 on both sides. So total is 0.25% moment is act on the middle strip and 0.75% moment is act in the column strip in both directions. And see the pattern of deflection. This is the pattern of deflection of the flat slab. Thank you. We will stop here. We will discuss the design procedure of flat slabs in the next lecture. Thank you.